Welcome back. Today we're going over area of composite figures. Now, area of composite figures basically means that we are taking the area of a composite. Well, a composite figure is made up of two or more shapes, and we can find the area of a composite figure by adding or subtracting the area of each shape. So, for example, down here, if I were to find the area of all these separate shapes, we could see that we have an octagon and we have a rectangle. So I could find the area of one octagon plus the area of the rectangle and find the area that this takes up. Right here, looks like I have a big giant trapezoid, a rectangle, and a smaller trapezoid, and then a little circle. So I could find the area of those shapes, add them together to get the total area of that shape. And then same thing with this door. If these were like windows that were cut out, I could find the area of the big rectangle and subtract each area of the windows to find the total area of the door minus the windows. Alright, so with that, here we have a composite figure. It's a shape made up of multiple shapes, and we can see that by drawing just a little line across the top there. We have a rectangle and we have a triangle. So the two shapes that we're going to be dealing with in our formulas here would be a rectangle and a triangle. The area formula of any rectangle is area equals base times height. The area formula of any triangle is area equals base times height divided by 2. You should have both of those memorized. To plug in the values, I need to know what those values are. So I look at the shape here. The base of this rectangle is 9, and it looks like the height is 8 of the rectangle. So I go ahead and use those two numbers, and I would write that out. Area equals 9 times 8. And hopefully you know your 9 times tables, so we'd go 9 times 8 is 72 feet squared. Then I can go to the next one and plug in those values, which this one right here, I need to know the height of this triangle, because I already know the base is 9, because it's the same as this bottom piece. But it tells me that this height here is 12. Well, that doesn't mean that this triangle right here is 12 tall, because that's 12 to the base of the rectangle. I want to know how tall it is from the height of this triangle to the base of this triangle, which that looks like it's the same ending point right there is that 8 feet. So all I have to do really then is to take 12 and minus 8 from it, and that would tell me the distance that it is to the bottom of the triangle. So 12 minus 8 is 4, so now I have a height of 4 and a base of 9. So I'd say 9 times 4 divided by 2, and that would give me area equals 18 feet squared. To get the area of the composite figure, I then just add the two pieces because they're adding to each other. They're not being subtracted. They're getting the area that they're taking up is bigger. So I add them together and I get 90 feet squared. So this shape up here has a total area of 90 feet squared. Alright, next shape. So if we look at this one, it looks kind of similar to the last one. I can see a rectangle in there. I could break this up into two triangles because it looks like it wants that, but if I notice when I draw this line over the top, it's actually just a rectangle and a triangle again. So I go ahead and take the information here, and I'm going to start by drawing my two shapes, and then the two associated formulas. Area equals base times height, area equals base times height divided by 2. And now I need to find the values to plug in. It looks like the base of this rectangle is 15 and the height is 9, so I go ahead and put those two values in. Area equals 15 times 9, and then with this one 15 times 10 would be 150, so just subtract 15 because you're only timesing 9 of them, so I would have 135 meters squared. Then I can move on to the next one, and on the next one I notice that the base here is the same distance as this one here, so that'd be 15, and the height is already given. So I would go ahead and say 15 times 5 divided by 2, and if I were to multiply that through, I would find out that the answer is 37.5. To get the area of the composite figure, because this is being added on to the rectangle, it's not being subtracted. If it was being subtracted, it would cut out a little hole out of that rectangle. But since it's being added onto it, I take my two areas and I add them. and if I did 135 plus 37.5, I would get 172.5 meters squared. Next example. So a composite figure also includes overlapping shapes. And if they include overlapping shapes, then there's some stuff that we have to do with this. But if you'll notice here, I have a rectangle here and I have a parallelogram, and they're overlapping, and I only want to find the area of the shaded region, meaning I don't want this area on the inside, I want all of the gray area. Well, to figure that out, all we have to do is we have to find the area of the rectangle, and once we find the area of the rectangle, we would then subtract the area of the parallelogram. And if we did that, then that means that this parallelogram would be taken out, and what would be left would be this shaded region. Okay, go ahead and try number 1 and 2 on your own and see if you can figure it out. Alright, so you've tried number 1 and number 2 hopefully on your own. And for number 1, we have a trapezoid and a rectangle. So I'm going to go ahead and use the area formula of a trapezoid. Base 1 plus base 2 divided by 2 times height. And the base here we have 15 and 10, and the height of 8. So I'd go ahead and say 15 plus 10 divided by 2 times 8. And that would give me a grand total of 100 inches squared. I then do the same thing for the inside here. That's a rectangle, so that's area equals base times height. We would get area equals 35, and so I just take 100 minus 35 because I'm getting rid of that piece, that's subtraction, and I would get 65 inches squared. So I know that the shaded region here has 65 square inches of area. Number 2 is unique, and the reason why it's unique is because this overlapping shape here, we have 2 spots that are overlapping each other, which means we're going to have double the amount of area that's overlapped. Instead of having a shape that's just on the inside, like this one here, you have one incomplete shape that's overlapping. This is 2 separate shapes that are overlapping each other, so there's twice the amount of area. So to do this though, I noticed at very first it says this patio, it's being landscaped with trees and shrubs, and how many square feet of landscaping will be around the patio. Well, that means the landscaping place is where I want the area, but what I've noticed is that this is a 14 by 8. This one over here is a 14 by 8. So I only have to find the area of one of them and double it, which means the same thing about here. The area of this inside patio, I only have to find one of them and double it to get that answer. So to start out, I'm just going to go ahead and cross off that patio area because we don't want that. We want to get rid of it, just as a reminder. And then I'm going to go find the area of each rectangle. In this case, it was 14 times 8. And then because there are 2 identical shapes, I'm just going to times that by 2. 14 times 8 times 2 gives me 224 feet squared. Now I have to find the length and the height here, or the base and height of this inside rectangle. Well, it gives me some information. So if I look at this, if that's 14 feet, and this right here is 3 feet, what does this have to be to make 14? Well, if this is 3 feet, I count from 3 all the way up to 14. That means that's going to have to be 10, or sorry, not 10, 11. And then up here, it says this is 3 feet, and so if this is 8 feet, that would have to be 5 feet. So I have an 11 by 5 rectangle, because 11 plus 3 is 14, and 3 plus 5 is 8. I then find the area of this shape. Area equals 11 times 5 times 2. And it's times 2 because we have 2 overlapping shapes. That would give me 110 feet squared. I then go ahead and take this because I don't want that inside area. I want to get rid of this. I then subtract the 2 areas to get 114 feet squared. Alright, go ahead and try the next 2 on your own and then summarize the lesson. Hopefully you understand that composites, they can be either added or subtracted depending on how they're cutting into a shape or adding onto a shape. If you have any questions, just let me know. Have a great day.